what they understood is instead of keeping the elements together, right, and solving the problem on a whole, like suppose I have this, I want to sort this array. And what we did in bubble sort was you went ahead each one, but we kept the whole array intact, right? It takes time, okay? So they thought, okay, let us reduce. Is there a way to reduce the complexity, right? Can we process the sorting faster? So what they said was, yes, you can. What you can do is you can divide them into smaller problems, okay? And keep dividing them. Keep dividing till you can no more further divide. Okay. Keep dividing into smaller problems. Okay. So you can still further divide this. Okay. You can till you cannot no more further divide. Like these are all independent units. Like in this case, in our case, it'll be what? Like these numbers would eventually be divided. Like so basically your array, you're going to divide. Okay. So this further you divide. Okay. This again, because you can further divide, you are going to divide some more. Now this you can no more divide. Okay. So that stays as is. Fine. This you can no more divide. It stays as it. Now, after you will reach a point after which you can no more divide it, right? They are independent units. So at this point, after, so this part is divide. Okay. Now you start conquering. Now comes conquer. So what conquer does is individual units, you solve the problem. Okay. So what is our problem? Our problem is to sort. Right? When you look at it individually, okay, say your array contains only 4. Is 4 sorted? Is 4 sorted? If your array is having only one element called 4, is that element sorted? Okay, now if you guys don't answer, I will have to ask you all to switch on your camera. Because I want this interactive. Are you all there? How do I know you all are there? You all are listening?
We are not. We are here, ma'am.
Yes, ma'am.
See, I know you all are paying attention, okay, but I need to see that in the responses, okay? So answer the question. So, because another thing is, if I ask a question and you answer right, we are actually slowing down and pausing, and it gives you some time to absorb the concept. And if I ask you and you don't know the answer, that is good, because now you will be more focused on finding out the answer, right? So both ways it helps. So my question is, suppose your array is having one element. Is that element already sorted? Yes, no?
No, ma'am. No, ma'am.
Why do you think it's not sorted? Okay, say suppose I have an array and the element is only 3. Okay, when do you say it is not sorted? When I have something lesser than that, right? Or I have something greater than that, something like this, right? Only when 2 elements come, you know that is, so the question is this in the ascending order? The answer is no. Is this in the ascending order?
Yes, ma'am.
Yes. So remember, your sorting applies only when you have more than one element, because you need to compare. Only when you compare, you will know, are they bigger, smaller, right? Less, more. You can do that only when by comparison. And if you want to do comparison, you need at least 2 elements. So if you have just one element, by default, there's nothing else to compare. So yes, it is sorted. Okay. Is this clear? This is very important to understand. Clear?
Yes, ma'am.
So now when we said, and when an array is having only one element, it is by default sorted. That means at this point, we have broken down the problem into such smaller parts that individual part is itself a solution. right? We have found, yes, 6 is sorted. Yes, 5 is sorted. Yes, 1 is sorted. In their own ways, yes, they are sorted. Okay. Now, when you want to conquer, okay, now comes the step of conquering. So now when you want to conquer, you look at the first element. Yes, this is already sorted. Okay. Now I will look at 2 elements. Okay. So now I will go back. So I'm saying each one of them is sorted. I have achieved the problem. I mean, I have found the solution. Okay. Now I go back to this step. So this step, yes, solution found. Now I go back to this step, right? Now I take 7 and 4 together. Okay. Now tell me, is this array sorted? Yes, no.
No, ma'am.
No. Yes. So here we need to solve the problem. So this you can solve. You basically you said that we need to compare each other, right? Compare each other, and you need to change it. So here you will apply some logic such that the answer of this is sorted. This is the answer. This is the solution. Now this one, it is already sorted. Okay. Now here 1 and 5, is this sorted?
Yes, ma'am.
Yes. So this is sorted. And this on its own is, yes, it is sorted. Okay. So at step 2, we have finished the step 2 and found the solution. Now we go back to step 3. So this is your 1, this is your 2, this is your 3. So in your divide, you're actually going from top to bottom. In your conquer, you're going from bottom to up. Okay. So now at step 3 is you look at these 3. So now your array will no more be like this, right? So your array will be 4, 7, and 3. These 2. So basically, I'll put it like this. Okay. You have to solve these 2 to get this. So now you have to solve these 2 to get this. Okay. Remember, we are not looking at this one. We are looking at this one. We are not looking at 7 and 4. We are looking at 4 and 7. That is important. Okay. So when you're solving the problem, look at the solved piece, not the original piece. So here, now we need to fix this 4, 7, and 3. Is this sorted? 4, 7, and 3? If
No.
it comes like this,
No,
ma'am.
ma'am.
So now you need to apply something and sort, right? So you say we'll come to how to do that. Okay. Same thing, some comparison you have to do such that you will get the array like 3, 4, and 7. Okay. One point to I want to highlight here. Okay. When we say divide and conquer, right? At conquering, you have to do something. It's not like simply you merge these two numbers and you will get the answer. You cannot do that. If I simply merge these 2, like I put an arrow here, right? You cannot say that, okay, 4, 7, and 3. Yes, this is the solution. No. When you merge it, you also have to solve the problem. Okay, that's very important. Okay, so we found 3, 4, and 7. Let's go to this side of the problem. Okay, so 1 and 5 is sorted. Let's merge these 2. So when you merge, you get 1 and 5. Are they sorted already?
Yes.
Yes. So 6, anyways, we said it is sorted on its own. Now, when you come to this step 2, so you have to look at when you merge, you get 1, 5, and 6. Is this array already sorted?
Yes, ma'am.
Yes, ma'am.
Merge this. So you get the answer as 1, 5, 6. Right. Now, coming to the last piece of the problem. So you have to merge here also, right? So if I simply merge this, I will get something like 3, 4, 7, 1, 5, 6. Is this sorted?
No, ma'am.
So you need to apply some logic here where you will do comparing each of the elements and come up with this 3, 1, 5, 6, 7. Okay, you need to do some computation here and then you find the solution. Okay, so how do you summarize divide and conquer? Something like this. Let's take this example. Okay, so it has 2 parts. So the red array, red arrows up till here, you're actually dividing. This is very simple. Dividing is very simple. You just need to keep splitting till you can no more split. Okay, this part is simple. Then when you come to conquer, from here on you're conquering. Okay, so at each step you check and you apply the solution. Okay. You want to sort these two. Then after that, you merge this, and then you have to sort individually these two pieces. Then you merge this and individual, and then this fully have to sort together. So this is called conc. Okay, is this clear?
Yes, ma'am. Yes, ma'am.
So you, if you get the question, something like explain what is divide and conquer, will you be able to answer?
Yes, ma'am. Yes, ma'am.
Okay. Can somebody want to give it a try in your own words? Can you explain what is divide? Okay. First, one person can explain what is divide. If you want to explain divide and conquer, first, how will you explain divide? Can you give it a try? How will you, in your own words, in English, you have to explain divide and conquer. Just look at this. How will you put this in words? What did you do when you say divide?
First, we should divide it, ma'am, until we are no more able to divide it.
Yeah. So what you can explain is make it general. Now you don't have to, when you're explaining, no, this is example. Okay, when you give an example of divide and conquer, you can take numbers and explain. But when you want to give the definition of what divide and conquer is, you need to be more generic, right? So what you say is, given a problem, okay, we keep dividing into sub-problems, till you can no more divide. So that is the definition of divide. So you have a problem at hand, you need to divide it into sub-problems till you can no more divide. Okay. Now, before coming to the conquer part, so this first definition, first half of your definition is clear, right? This is how you need to explain divide. Now, when you come to, before you come to conquer, okay, this step is very important. So once you have divided such that you can no more divide, what is the assumption here? So this is your part 2 of your definition of divide and conquer. Okay. What is the assumption here? Individually, they are sorted. So how will you put it in a very generic way? Individually. We are saying problem here, right? We are not saying sorting, any kind of problem. So individually, what happens here?
It's sorted, ma'am.
Sorted is one example of a problem. So what you can say is individually, the problem is solved, right? Correct? I'm generalizing the same definition. So at this point, when you can no more divide, individually, each of these problems is solved on its own, right? Then comes the conquer. So conquer, what do you do? So what do you do is
numbers, ma'am.
What you can do is you can say merge. So you have these two individual solutions. You are merging them to find the problem. So a solution. So merge these sub-problems. So merge the solution. Merge the solution to sub-problems to find the solution to bigger problem. Okay. So you need to mention 3 points when defining divide and conquer. Is this clear? So you should be able to write the definition of divide and conquer, and it should include 3 points. Okay. So let me, what we'll do is I'll just bring up a highlight of this problem, and then we will go in detail in the next class. Okay. So how do you write a merge sort? Okay. So this is how you're, this is just a starting point, right? You have some array. Okay, you're just printing the array to say before sort. So this one, you're just printing the array. Here print array, it's actually a for loop which goes through each element and just prints it in this fashion. Okay, that's it. It does. Then you call the actual function called merge sort. It does something. Okay. After which this array, if you print again, it's the same thing. Print array, print array. You see that the array is sorted. Okay. So now this is the important piece. What did this function do such that the array got sorted? Now, one more thing, right? Let me go back to the problem. If you see here, we are doing the same operation again and again and again. So here we have an array. What it did was it divided the array into two arrays, two sub arrays, right? What did we do here? This one we divided into two sub arrays. Okay, okay. Let me say this is after this, after doing this step, you get this two. So what did we do here to get these two? Which
Again,
operation?
divide, ma'am.
Yes, we actually same thing we did. Divide array into two, right? You would do the same thing here also. Here also you will do the same operation. So the same operation is repeated again and again and again. Okay, but your input is changing. Here the input was an array of size 4. Here your input is array of size 2. Here your input is array of size 1. Okay. Does this ring a bell? Does this definition sound something familiar? When you have a problem and you're calling the same function again and again with different inputs or with smaller inputs, what can we do?
Recursion, ma'am.
Perfect. Recursion. This was exactly the definition we gave for recursion, right? When you have a problem at hand and you're doing the same operation again and again and again with slightly different inputs, we can, this is the perfect case for recursion. And that is why, and if you look at it here also, so here you're actually doing merge array. You're doing the operation merge. Here also you're doing the operation merge. Here also merge. Right? So here also merge operation is being done again and again and again. So if you have to write a merge sort, it looks very simple, just 3-line statement, right? What are you doing? You're calling the same function, merge sort, okay, but with slightly different input. So when I say dividing the array, all we have to, like I said, no, we will be playing around with the array indexes. You don't worry what the number is. You have to be careful with this one. Okay. So here, when I say, okay, there is an array here, left and right. So left means it is pointing here. Okay. Right means it is pointing here. Okay. So how do you divide this array? It should come like this. Okay. So what do we have seen this in binary search also, no? You have to find the mid. Okay. Mid is left plus right by 2. So here you will say left plus right by 2. So 5 by 2, you get it in decimals, which will, if you're doing an integer division, it will return just 2. Okay. So that means your mid, you found this M, okay, which is pointing to 2. You find the mid of the array. This you should be very familiar because we did in binary search also here. Okay. 1 second. Okay, sorry for that. Okay, so we'll make use of this mid concept. we'll make use of the mid to split the array. So if you see here, they've actually split the array. Okay, now they are calling merge sort. Okay, on a smaller input. They are passing left. So your left was still here. Okay, left. And what is this index? Mid. So that means they have split it like this. So you are passing your array with so much left to mid. Left to mid means you have actually this part. Okay, you're calling merge sort on this part. Then you have to call merge sort again with m plus 1 to right. So m is here. So m plus 1 will be somewhere here to right. That means this part. Okay, is this clear? Like this, you need to be like 100% clear. Then only you will understand. Otherwise, it will get complicated for you. Did you understand how we split here?
Yes, ma'am.
Okay, good. Okay, so be careful with this one. So how will you say? You will say m plus 1. And this you will say right. And even for binary search also, you did the same thing. When you say search towards the left of the array, you did this. When you say search towards the right of the array, you did this. But there, we skipped mid. We had already done this. So you did m minus 1 here. Okay, and then you did m plus 1. Right? Because mid you had already processed. So sometimes, when you put at the end of the semester, when you go through binary search, merge sort, right, you will get confused why here it is m, why in binary search it is m minus 1. You need to clearly understand what problem we are solving. Here, we need to include this because we have still not completed the problem, right? We are just splitting the array. So you need to include mid. Okay, so you call this. After that, what it says, after splitting these two, you need to call merge sort. Okay. So before that, right, how this recursion works is when you call this first time merge sort, this is a recursive function. So this will keep going on and on and on till we said that you need to break that recursion. Okay, where is the condition to break the recursion here? This one, right? So this is again important. Our recursion is broken by this. When it is saying that your right is greater than your left. Okay, so as long as your right is greater than your left, right? You keep merging, splitting. Okay. So at this point, okay, let's see. What is left here? Look at this array. What is left here?
0.
0.
What is right?
2.
2. Is right greater than left?
Yes, ma'am.
Yes. So if it is true, what are you supposed to do? Call merge sort again. Yes, you need to recursively call merge sort again. So again, you will call merge sort. So now you need to split this array. Okay. So you will come back into this. So this is your one merge sort. Okay. Merge sort function you entered here. So again, you are entering merge sort function here. So in this again, from the top, you have to check the conditions. So what will your first, you have to check this condition. So you have to say, is your right. So in this case, same thing, your right is, okay. So now before this one, before completing this merge sort, you're actually calling this second merge sort function. Okay, you're calling the merge sort again with what inputs? You're calling it with array. Then you're saying left and right. Okay, so you pass left and you pass right. Okay, so now you come here into this, you say, yeah, left is greater than right. I need to split it again. So left is greater than right. Right is greater than left. I need to split it. So what is m here? What is m here for this input? What is the m?
0, ma'am.
So it is 0 plus 2 divided by 2, which is 1. Okay. So then you split again, call merge sort now. Okay. So basically now you're dividing this. Okay. So here you're in. Just quickly finish this. I need to start another meeting. So at this point, you're looking at this array, right? So it is 0, 1, 2. So your left is here. Your right is here. Now you found out the mid, your mid is here. Okay. So how will you split this? Your first merge sort is your left to mid. Okay, so this becomes your first half. Then your second half is mid plus 1 to right. So mid plus 1 to, so basically both are pointing here only. So mid plus 1 to right, this is your second half. Okay. So at this, then you call this again, you're again calling merge sort. If you look at this, at this point, right, you will hit the condition. Is your right greater than left? For this array, your left is also here, your right is also here, because you're calling merge sort only with this one element, right? So in this condition, is your left greater than right?
No, ma'am.
No. So at this point, you will break the recursion. Okay. At this point, this will finish executing. Okay. And then because, so this is your left side, this is your right side, right? So your right side would have finished executing. Okay. Then it will come and hit the call the merge. Okay. So till here, we are actually, when you call this recursive function, these two are actually only splitting. So these two are only dividing. Okay. Then there is a separate function called merge. This is not recursion. Okay. This is merge sort. This is a different function called merge. This is the function which will actually do the comparison and sort it and do it. This function, we'll look at it in the next class. Okay. I'll share this, just go through this, be familiar at least with the first part, like why are we calling two recursions, draw this kind of a diagram and understand how these two will work. Okay, so we have covered these two. This one we'll cover in the next class.